let's walk through implementing a parser. Let's walk through implementing a parser. Here's the way that it works. I guess I'll share my screen again. All right, so let's have the regular IntelliJ idea. Which will hopefully not crash immediately. So the way that you do this is largely trial and error. That's sort of just the reality of it. So for example, right, let's look at the query parser. Right, here it is. Here's the query parser. And there we go. Here it is. Right. So these are different structures that you need to be able to parse. Okay. So, for example, let's have a look at something like let's see. Let's say union. Well, interesting enough. So you look at this thing and you're like, okay, well, I want to create something like this, a clause for doing something like this, and I want to create it where's the parser? Parsing Macro, translation. Oh, whoops. And I want to create something like that in, let's see, query parser. Here's the query parser. Over here. Right, so here's a query parser. You know, don't get worried about all this stuff here. A lot of it is just semantic noise, right? This could all be on one line, this could all be on one line, and there are a bunch of random comments that I have that should be commented out, random print statements, so the vast majority of this is not that consequential. I have these random insertions of type T and some other stuff. Most of it can be ignored. This pattern that I use sometimes is just, I might have mentioned it before, if you need to use this T multiple times. Like, if there needs to be a T here and another T somewhere in there, then I use this pattern of taking this thing and moving it out to doing type T. And then I do it here, and then potentially, you know, we looked at an example of this before, although this doesn't actually work, but if you wanted to do some lambda argument to output or something like that, and the lambda needs to get typed on T, well, that's a problem if you declare T both here and in there, right? So you can't declare it twice, and if you try declaring it 2 times, the compiler will fail, and it'll tell you, oh, this guy has to be this guy, right? We can actually try compiling this thing, and it'll tell us. Blah, 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 blah. Oh no, big problem. Not found arg. Oh, whoops. Excuse me. You need to put $signs, right? Everything that you're attempting to pull out of this thing is a $sign, right? Like, the best way to think of this thing as like a giant string. And indeed, if you look at query schema here, let's look at query schema. Blah, 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 right? This is a freaking string, right? This is like really a fancy string. How do you make variables that you can pull out of this thing? Make dollar signs, right? This is basically the same thing. You can treat this as a big fancy string. No, it's not, and it's actually a typed construct, blah, 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 blah. It's a string, really, at the end of the day. But here's the thing, right? It's complaining, oh, no, this TT is not... wait, hold on, no. We have to add the dollar sign by the arg. Okay, here we go. Oh, we have to add the dollar sign by output. Again, because these are all variables that we need to declare. Otherwise, it literally thinks there's something called output here, which is wrong. There isn't. Oh, there we go. Found tt.t output.t requires string. Okay. So we have this type here, and we have this thing here. Oh, by the way, there's, we got the syntax wrong here. This is actually, this has to be this. Okay, so anytime we type on something, we need to create this parenthesis around this whole thing. So let's create a parenthesis around it. Okay, there we go. Type must be fully defined. Now we're starting to get somewhere. It doesn't like the fact that there's no type here. Remember that in this, unlike in this here, right, in this here, you can sort of just declare things with dollar signs. With this thing here, every dollar sign needs to have a type. What does that mean? You need a colon and give it a type, like int or string, or in this case, we don't know what the heck it is going to be because we're not sure. Actually, for output, it's query schema, so we do know. We do know what this is because we can actually look up what query schema is. And we can look it up from here. Let's see, query schema. And IntelliJ is your friend, at least when it works. And we can actually see, okay, what is going on here? Oh, right. Okay, so the first argument to the query schema is a string. The rest are a bunch of these weird tuple thingies. So, I don't know. Oh, what I'm doing here is actually wrong. This is not correct. And so I could try that. So what this means is match on query schema dot output. That doesn't seem to make much sense because we need to match on this, which is a string, and this, which is that. Well, we could try directly pasting that into here. Right, that should kind of work. And then put dollar signs by everything that represents something that we need to get out. And we could try to replace this T with a type here. But if we try that, then it'll just fail horribly. So, not the right way to go. So the right way to go with this is like trying to, this is roughly the structure, right, that we're matching because we're matching a construct that looks like this. And for examples of how something like query schema is used, by the way, ask me where to get the examples because they're all in the tests and I'll show you where, which is actually one of the things that we should do. Like, I'll show you all the places where you can find examples of the kind of code you're trying to match. Like that leave that to me. Tell me, I need examples of such and such code. I need examples of such and such construct for parsing. Tell me. Like, I will tell you immediately. Look at the code here. This is an example of it here. Run this test here. So don't worry about that. So here's let's see. Let's find an example of how this thing is used. Blah 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 blah.
There you go. Sorry, I'm so late.
No worries. I think we should have everything in. So let's see. Where can we find query schema? Query schema val query. Oh, no, equals to query. Oh, there it is. Okay. So here's an example of how a query schema is used. So you declare a query schema with some kind of thing here, and with some kind of... Well, actually, you don't need anything else. Technically, this could just be a string. Well, that's pretty easy, because then you could just do that, and that would work. Right, this will actually compile, and this will actually work. FYI. Wait, no. I guess I'm wrong. Let's see. Not found error, properties. Oh, yes, of course. Because this variable that we just had up here before no longer exists. Right? This thing here before was... that stuff here. Right, so this thing that's here no longer exists. Right, we remove that, which is why it's complaining that this variable isn't right. But anyway, what I wanted to show you was this. Let's get rid of this comment. Right, you could do something like, okay, let's take all this out. Let's take all this out. You could do something like this. Value string. And that will even compile. Right? You could do something like that. And then I don't know, return null or something. And that should work. Or not. Oh, right. You have to get rid of these squigglies. So you could actually do something like this, and it should compile. Okay, there we go. Now, except for the fact that, well, what kind of construct will this match? Well, how do we get that information? So, the best way to do this, if you're trying to, like, actually add clauses to the parser, well, just print stuff. So what you typically want to do is just lots of print statements. Matching this. So if you do that, then there's this thing in here called the mini quill test right now, and I'm just using this as a staging round for testing. If you do something like using this, and again, I'll show you examples of that. So here's a query schema, and here's a value of it, which is a string. So that means that the code that this will be parsing will be something like query schema, and then some kind of t, but again, in Scala you can omit the type usually, and then let's say foo, right? So that's the kind of construct that will match in here. Well, let's see. So we can do val, let's say run. In fact, we don't even, I don't think we need that there. We don't need to run it yet. I just want to show you this example. Let's see. Val output equals to quote of that, right? Because everything has got to be in quotes. And, okay. I don't think that those problems are real problems. Let's see. Let's try to compile it. Again, never trust these squiggly red lines. They may or may not be lying. Null pointer exception. Ah! Here's our print line. So we did actually match this thing. Yay! Well, except for the fact that, again, the way that this thing is used is to define a, well, it's not used here, but the way that this thing is used is to alter a query. How is this thing actually used? Again, ask me. Ask me and I will explain. The way that query schemas are used, see, normally, let's say case class, person, name, string, age, int, right? And when we have something like, let's say run query person dot filter p2 p dot name equal to Joe. I'm sorry. I need to import the entire Quill context. There we go. All right, so that will give us some simple SQL with a filter. All right, simple SQL with a filter. Well, here's the thing. What if you want a table that is person, but let's say it's not from person. Let's say it's like from TBL person. Well, then you kind of have to create this ugly case class that looks like this, right? And then you kind of have to do this. And that'll work, but that's ugly because you're breaking, like, the way you're supposed to declare classes in Scala or most other languages. And then let's say it's not name. Let's say it's not a column name. Let's say it's select p dot call name, because all columns are prefixed with call, you know, because DBAs like to make arbitrary rules about what things have to be called. So, okay, fine. Let's say call name. Okay. Oh, yes, it's call name. So this is sufficiently ugly to want to barf. So the way that you're supposed to solve this sort of problem is use this magical query schema thing. Right, now let's separate this query into two pieces. Let's say Q equals to quote query of TBL person. Okay. And then, of course, we can use our Q. Or what we could do, let's call it Q1. It's not query of TBL person, but let's go back to our original person. query schema. Let's declare a different name. TBL person. Oh, perfect. And now, what do we want? We want that. Oh, wait, no, hold on. That's our original Q. Let's have Q1. Oh, wait, what did I do wrong? Val Q1 equals to quote. Oh, yes. I didn't change name to call name, which is going to be a problem because it needs to be call name and not name. Let's ignore that for now, right? But this did work. It did change the name of TBL person. Okay. So how did I do that? Well, I use this query schema thing. Here we go. You use query schema with TBL person, and that's how you do it. Well, where does this get parsed? Voila! Right here. That's what parses this construct. Ooh, except for the fact that you have these properties here. What are they? What are they? Well, first of all, if we go back to the definition, well, it's star. So whenever you see a star, that's a var args in Scala. So for example, let's say def, let's say print all equals to items string star, and then let's say items dot, or let's say items dot, let's say map item, and let's say I don't know, item colon plus I mk string, separate them by new line characters, whatever, right? Star is a var args, so print all foo var as, okay, item foo, item bar, item baz, okay? Oh, by the way, this whole thing is a big multi-line string. Okay. So, this is some kind of var args. What is this? Well, we touched on this a little bit last time. The way that this works is that this lets you actually change name to call name without having to manually do it yourself. The way that you do it is like this. Underscore dot name arrow call name. And then you do that, right? And now it's just name. And voila, not only is it TBL person, but it's also call name. All right. So what is this underscore dot? Well, what is underscore dot in Scala? What is that shorthand for?
What it was before, so like over here would be a person.
Yes. So it would be some p, an arrow function to some p dot name. And in this case, this is person. Voila. So it's basically, and oh, again, look at how this thing is defined. Okay, we have a lambda that goes from t, which is the type of query schema, which is, ta-da, person. And that t here goes to, what's this? What's this? Oh, remember how an arrow function, foo to bar, is actually a tuple? Or becomes that? Interesting. Then p.name, well, that's a string, but we could just as easily have p.age, which is an int. So really the type of this thing can be any. Oh, any. And of course it's varargs, because you can do multiple. P person arrow p dot name goes to call name. So the second thing will always be a string. The first thing can be anything. And okay. What did I do wrong here? Not a legal parameter.
It needs to be a tuple, doesn't it? So,
Oh, no. This. That has to be an arrow function.
oh, never mind.
Fat arrow, because a fat arrow is a lambda. Oopsie. Voila. So now we have call name, call int. All right. Now we are getting somewhere. Except for the fact that, again, when you have a lambda like this, you can shorten it. And the way that you can visualize it is like this. List of foo bar baz dot map string to string dot length. Alternatively, that, right? So here's super longhand, right? And then there's shorthand, because type auto inference. Yay, local type auto inference. And finally, the shortest of the shorthands. Okay, well, guess what? We can do the same thing here. La 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 la. La 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 la. And run. Voila. Same thing. Okay. So, query schema has this nice little mechanism of being able to specify a table and multiple columns. And except for the fact that we need to parse these things. And how do we parse them? Well, we parse it like so. What does this look like? Oh, please skip this. Skip this for now. This we will not touch on until later. Right? It's entity. Dot opinionated, you can think of it as a particular constructor of entity. And, okay, it has a name, and then these property thingies that we need to be able to map into this property alias parser thingy. Okay. So this guy parses these guys. Okay. Now, here's the thing, though, right? So we've managed to create in the parser, like, a small construct for doing this. But doing properties is kind of harder. Right? Well, first of all, by the way, this value thing, well, what is value? Notice how whenever you put a dollar sign in here, what this thing will be, once this thing tells me, hopefully. Come on, tell me what this is. Do I have to compile? No. Compile. Sometimes you need to be able to return something from here. And that's actually, so I want to be able to get into this code, but I just want to be able to compile it. I can't just do null, and that doesn't work, because that'll give me a null pointer exception elsewhere. So, in this case, sometimes, and again, if you need to do this, ask me how, but we can synthesize a fake thing, and then a list of fake properties in here. So, okay, what happened here? Oh yes, missing. We need one more argument, which is this thing. Let's see, we can synthesize this fake thing here. Okay, good. And will it tell us what this is now? Come on, tell us what this is. It is not telling us what this is. Let's try to restart this, because it definitely should tell us what it is. Launch IDE. And by the way, this should be able to compile now without errors. La 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 la. To apply latest update. Release notes. What's the latest update? Okay, I don't care. At least not now. Okay. Come on, tell me what this is. Loading. Well, we're doing something. Voila. It's an expr of string. It is not a string, right? We need to create one of these, and we at least need to pass something as the name of the entity, right? Because, oh, what's the AST that we're producing? How do we find that out, right? We kind of want to know what the AST of this is. Q1.AST. No, that is not what I want. Why am I showing that? That is not what I want. Let's see, can I do a show? Shoot. That is not what I want. Q1.ast io.getQuill util qprint. Oh, sorry, messages. Qprint entity that's odd. Sorry, 1 second. That was very unexpected. System set property. Hold up. Trace.asp.simple. False. Oh, I know. Shit. Oh, I know what's wrong. I know what's wrong. How do we fix this? I know what's wrong. Why is it that? Can we just do different apply? No. Plain text. Well, that's better, but not what I want. Show. And can we do that? No, we can't do that. Render? Ah. Okay, so what's happening is that it is not printing this thing out correctly for me, and it's not showing it in the right format. So I need to look into why this is doing it. I know. Sorry. You know what? Actually, you're not going to have to deal with this bug yet. This bug exists in the latest version of Quill. You are not going to have to deal with it because we're not using this version. This actually shows up in 3.6.0 RC3. You're going to be using 3.5.2 for now, so you do not have to worry about this problem. I have to worry about this problem. Sorry. Okay. It's good that I discovered that, so I can fix it. Anyway, case class person, and then we were doing val q1 equals to query schema, and we wanted the AST. So there it is. Okay, so this is what we're producing, right? Entity, TBL person, and then this list of properties. Well, except for when we don't actually make any of these properties because they're var args, we don't actually have to specify it, hence empty list. There's also another argument here that it's not showing, which is this thingy here. Again, if this is important, I'll tell you. It's not. You can, in this case, at least for now, you can do that. So, okay. So we, excuse me, we're here. So we want to be able to create this thing here, but this value thing here is an expr string. How do we get a string out? So again, look around and see the patterns that I've used. In this case, here's the thing, right? This thing can be any string. Or at least the user can specify any string. Right? When the user actually creates one of these, the user can put some blah blah in here. So long as they create it first. Except for the fact that I actually say no. You can't just specify any string variable. Because that's what Scala.quoted.expr of string is. It's an expression of string. It's any string variable. That's what blah, blah, blah is. Right? When this thing goes into the macro, what does the macro see? The macro sees expr of string here. Why isn't this a comment syntax? Okay, whatever. No, that should actually be a legit comment. I don't know why this thinks it isn't a comment, but whatever. So, you can't just use anything, right? When using macros, when it says a constant, it's got to be a frickin' constant, right? So it's a frickin' constant. Now, how do you actually pull out a constant? Like, how do you know that this thing is a constant when you're trying to parse it? Well, ask me, Or here's how I did it. Constant expression. Okay, so now you can use this instead. Well, that'll work. Fine. And now value, wait, value doesn't exist. It's now name. Name is actually going to be, we can put it in here, it's a legit string. Okay, so name is a legit string, so we can put that there. And so now we can actually parse something. Okay. Let's open up SVT. Compile. And again, this mini quill test thing is just a staging file that I use to test different things. So we can modify it here once our compile is finished. Again, just modify this thing in some sort of way. It'll force the file to recompile and run your code. Okay, well, here's what we ran. We ran this guy here, and we parsed it here. Okay. And now we need to be able to parse the properties, which goes into the question of, wait a second, how do let's say I take a construct, like I was saying before, with the, I don't know, the union parser, right? How do I know what tree this represents? How do I know, right? Like, how do I even get started on something that's new, like this, right? Or how do I know what this is supposed to match? How do I know how to parse something like this? So this is where we sort of have to take a step back and we have to say, no. The first thing that we've got to look at this bottom up, right? Like, we're working right now top down. We're saying, okay, here's what the parser looks like today, or here's what the construct looks like over here, and let's write it over here and sort of try and get it to work. That works for basic constructs. For complex things, it just doesn't work that way. Unfortunately, it just doesn't work that way. What you have to do is you actually have to go the opposite way. You have to go bottom up. Here's what I mean. Instead of trying to figure out what kind of clauses to write in the parser, first of all, look at what the tree looks like, the actual AST tree, and try to get a parser to match it, or some variation of it. Once you've got that, try to build some kind of clause that matches it. So let's not look at this. Let's look at something like union parser. Right? How do we write something like this? Okay. Well, the first thing we need to do, again, bottom-up approach. First, let's make a statement that is actually of this. That is actually of something union something else. Right? Let's make a statement that looks something like this. Let's open up let's open up our original project, our original example code. So, right, we wrote a example printing macro, and we have it here. Like, we can print things. So we have an example printer. So use simple quill 2, right? Let's, use simple quill 4. Let's just use this for our purposes, right? Now, also what we have in here is we have the quill code base, right? We've imported that. So we can import io.getQuill, right? And then let's actually try to create something union something else. So let's see if we can pull this off. What's an example of how we would do this? So let's look at where union is used. Let's look at an example where union is used. And again, you can look for these in the tests. If you need examples of these, I will provide these. Okay. Here's an example of how union is used. Okay, well, that's complicated. Let's see if we can find something simpler. Well, if you really want a simple example of how union is used, then just go here. Right? And union. Here's union. Here's how union is used. Okay, so this is actually even more complex than it has to be. So union person.filter, p.age greater 18, okay, blah, 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 blah. Okay, we can do this, right? We can do this. We can declare person with an age column. Again, Ammonite is useful for figuring this stuff out. So let's say we created case class person, name, age. Okay, we could try this. And then let's run. Okay, so, all right, we had, what did we have here? We had person filter where age is greater than 18, person filter where age is, greater than 18 and greater than 60 or something like that. And here we have the union of the queries, where age greater than 18, where age greater than 60. Okay, so we have these two queries here. Could we simplify this maybe? Let's see. Can we just do maybe query of person? Query of person. It's kind of redundant, but let's see what happens. Run Q. Oh, there we go. Select X name, X age from da-da. Select X name, X age from person da-da. Okay, so that's a simple union. So now we're matching something like this, right? This is what we need to match approximately. So, okay, let's see if we can just put this in here. All right, let's see if we can do something like that. And again, inline def, it's all inline def from now on. My union, right? And we need to declare person. Case class person name string age int. Okay. Union is not a member of blah 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 blah. Query person dot union. Do we have query? Union is not a member of org dot stuff dot query. Query? Oh, wait a minute. Oh. Right, it thinks that we're using query from the org.stuff package, since that's what we have imported here. I copied, let's see, one second. So this is when we were doing our toy DSL, but I don't think we need this anymore. Let me just comment this whole thing out. And then, let's see what happens now. Can we compile? Or do we have stuff that's dependent on this toy example that we made? Oh, wait, no, hold on. Oh, yes. What did we do here? Oh, we're still using this toy DSL. We're still using this toy DSL. I don't think we need to use it. Let me just double. Wait, hold on. Oh yes, yes, we're still using the toy DSL we created here. Let me fix that. Let's see, in which quill are we using? The 352. Oh. 352. Okay, we are on 352. And yeah, we have to reload something. But anyway, let's see. Sometimes when you're in WSL and you need to reload files, you actually have to manually tell it to reload them. But anyway, oh, and now it's re-indexing them. Let's look for, well, it's going to be in, well, all these things are ultimately defined in Quill Core Portable, which is actually the core module that defines everything. So, in fact, it's model that defines the DSL. So here's model. Right, here's query union. And here's union under query. But, okay, there's query, but then the question is, how do we construct one of these, right? Query here. This is a constructor of the query type, so to speak. And so we need a way to call this thing. Wait, DSL? No, where do we have this? Oh yes. Okay, so I've implemented it here. I've implemented it here. No, this is all correct. SD.query is a query. Oh, this query has to. Oh no, this is not supposed to be org.stuff.query. This is supposed to be. Import io.quill. Okay, compile. And type not found. Why is it type not found? Oh, this is quotation. Oh, yes, again. Import io.quill. Come on. Import io.quill. Right, because getQuill is where getQuill, io.getQuill is the package of this model object. And basically, right, Scala is a little bit like a scripting language in the idea that you don't have to have a class be named the same thing as your file. So the model.scala contains the query object, which is what I'm importing into all these files that they compile. I thought I had done that earlier, but it's my fault. I'll do that right now. Okay, there we go. There we go. Now our macros are kicking off.
Is it me lagging, or is Alex lagging for other people?
Oh, am I lagging?
Occasionally, but it's still, I can still understand.
Yeah, no, you're totally audible, but sometimes you lag out. I'm wondering if it's my.
I mean, I have a stutter on my end too. I just thought that was my end.
My machine
Okay.
is stalling right now because it's doing a good deal of processing. It should be done with us in a second. Actually, let me. Ooh, I am. Wow. My CPU is like off the charts. 1 second. Wow. Okay, what is going on here? Whoa. Why am I? Yes, my machine is lagging. Why the heck is this lagging? Sorry, 1 second. Why is this? Oh, is this IntelliJ? I think this is IntelliJ. I think this is IntelliJ. Sorry, 1 second. Oh, yes. IntelliJ is indexing. Yes. When IntelliJ indexes, it does a whole crap ton of I/O. And that, of course, causes lag. So, let's see. What is this? What is this indexing right now? This is re-indexing my entire project. You know what? Stop. Let me stop this re-indexing. I don't need it to do it now. Come on. Indexing paused. So what's happening is that, again, this is the challenge with IntelliJ. It needs to build this giant index of everything, and when it does, as it's doing it, it needs to consume a whole bunch of resources. What I just did was I switched a major version of Quill, and which is different. And so all the jars, or a lot of the jars at least, are different. And then it's going, whoa, I need to re-index all of your libraries, which is what it's doing. And that's why it's taking so much I/O. And because it's taking so much I/O, my entire machine is lagging. So it's updating its indexes.
So IntelliJ could just consume all of your multiprocessing.
Oh yeah, it can consume all of your cores, all of your RAM, all of your resources easily.
That's
Easily.
hilarious. I mean, there must be a way to limit that, right? Because I think that's a bit excessive, right?
Well, again, it only has to do it when it builds the index, like a full index cycle, right? So the idea is when you're managing an index for doing, something like IntelliJ symbol searches, right? When you're managing an inverted index, which is what that thing is, there are two things. There's like a mini index update, and there's a full index cycle where it just chucks the old index and rebuilds it from scratch. When you do something like substantially change your project dependencies, it has to run a full index cycle. And that's when it really, really consumes all the system resources. It doesn't always have to do this, right? It doesn't always do this. But it, at least once per the lifetime of a project, especially if you've got a lot of dependencies, it will do stuff like this. It's almost done now, though. And also, as it does it, your machine will sound like a jet engine.
Yeah, that's what's happening to my machine right now. I'm reinstalling Windows as we speak. So a lot of all my cores are zooming.
And not just that, I just have like 2 IntelliJ open, and yeah, that itself just messes my entire computer up.
Oh yeah, with 2 IntelliJs, my god, that is just asking for punishment. But anyway, okay, it's done now. All right. So, as we were saying, okay, so we've compiled this thing. We're good to go. Wait, no, not this thing. Excuse me, this thing. We've compiled it. We're good to go. So, let's use, right, we want to be able to use this constructor that we've defined, right? We've actually defined this right here in our mini DSL. We've defined this guy. And you can kind of play around with it. The reality is that when you're doing it, and you can, this is actually nice because you can play around with these things here if you want to be able to define something like that here. So then you could do something like print mac of union, right? And then a line of, you need to actually like do something with it, I think, during runtime, otherwise it will remove the variable. So here we go. Here's what union looks like. It's .query .union, the function, and then .query inside of it. Okay. Here's what the construct actually looks like when in the DSL. So we have, okay, so these, right, these are type ascriptions, right? The typed we can ignore. We're applying some list of arguments, and we're applying them to a query and a .union function, and then we've got some other types here, but really it's the extractors that help us the most. So and one other thing. Oh, notice this inlined thing, right? Whenever there's inlined, it's because we forgot to do underlying argument, that command unseal.underlying argument. So let's actually quickly change this in our printing macro. Let's do unseal.underlying argument. That show extractors. So let's, oops, now it's going to show us a whole bunch of stuff. But we don't want a whole bunch of stuff. Again, because we recompiled this, everywhere where this print is used gets recompiled, which is why we've got a ton of stuff, but we don't care. We just want to see that, so let's make a small change and recompile it. And now we can see the tree. Okay. So now we've seen the tree, and again, it's these extractors that's useful. Sorry, this thing gets printed out. I can't control it. This is just crap that happens. But here, roughly speaking, this is what we want to match on. This is what we want to match on. So let's see if we can do that. Right? So a couple of things, right? Now, the other thing is that we have a parsing macro where, we can have like an example of a tree that we're going to parse, right? So let's try to do that. Let's try to use our parsing macro to parse this thing. So you take this thing, you plug this into the parsing macro, And again, this is irrelevant. So, okay, let's see if we can parse it. Let's see if we can parse it. And again, when we recompile the parsing macro, oh wait. Oh right, because we used variables here that we're not using anymore. Let's just see if it matches. So let's try to use our parsing macro. And again, we need to recompile this file. That's why it's not showing anything. And let's see. Oh wait, we didn't actually invoke the parsing macro. So let's comment out the printing macro and let's do parsing macro, parse mac. Okay, I have to change the names to actually line up with the names of the Scala files, at least to make it simpler, but my bad. Let's do that. Okay. Oh, it does not match. Oopsie. It does not match. And then if it doesn't match, it prints what it is. Why did it not match? Let's see. Okay. So I didn't do this typed thing. This type thing is something that we can ignore. We just can't ignore it here. So let's put the whole thing with the type thing, and it should match. Again, the compiler's printed a bunch of garbage that we don't need. Okay, so it doesn't match. Now, the typed thing is a construct that we don't want to care about. So let's actually just add it. Again, I've done a lot of this, but there's a function that actually just makes it ignore it. And I've got that. Untype expression, untype. Basically, untype means just ignore typed. Because here's the thing, right? How does typed work? Well, actually, let's see how typed works, right? Let's see what this thing is for a second. Let's not do this. Right, let's do, let's say inline def my string equals to hello, right? And then we do print mac my string. Wait, do we actually have to do print line my? I don't think we actually have to do that. I think if we pass it to print mac, it's enough that the compiler won't skip it. Let's see if I'm right. Oh yeah, I'm right. Okay, fine. So again, please ignore object foo. It needs to be gotten rid of, but again, for it to actually parse, to be able to format this thing correctly, I have to add it, right? So please ignore this. Now, okay, here's typed. Typed, literal, inferred. Why is it typed? Well, this is one of these nasty things that you just have to remember. What if we don't do unseal? And again, it'll print everything, not what I want. Hello. We have two inline blocks, which is also, and a bunch of garbage that got here. Okay, I don't care. Okay, let's actually put hello directly into print mac. Let's see if we can do that. Okay, now we just have one inline block. Now, okay, fine. Let's ignore this for a second. Now let's add a type description. Okay. Let's see what that gives us. Oh, look at that. That gives us typed. Okay, let's do it twice. Okay, now it's typed of typed. Okay, let's do it 3 times. Okay, now it's typed of typed of typed. And then the actual literal constant string. Does this make sense?
Yeah, so far.
So type, so basically doing this type description just introduces this AST element. But when we're actually parsing this string, we really don't freaking care about this thing. Like, it really makes no difference to us when we're creating the Quill AST. So we just want to get rid of it. So, which is why I have a utility that does that. It's called untype. And basically, right, it's a typed of typed of typed, which is like a Russian nesting doll. So in Russian, it's called a matryoshka. So I call it, typed matryoshka term. So basically, it just recursively gets rid of this type block. So, okay, let's just introduce that here. And let's introduce that to our parsing macro, because that's where we want to get rid of it. So let's just introduce that over here. And, oh wait. Okay. So, all right, so here's our untype. Okay. Now, then we can do unseal, right? Unseal is what allows us to use this term land, right? It allows us to use AST land. So then we'll add untype to it, which will get rid of the type garbage that we don't care about. Well, not garbage. Very important to the Scala language, but again, not in our use case. We'll just use that. Okay? See if that works. And right, because nothing needs to recompile forcibly. And let's do that. Okay, well, it still prints the string with them. Fine. But let's see. Actually, we can actually untype the expression as well. We can actually untype the tree as well. And that's what we do with this apply method here. So let's just introduce this. And again, if this was code that I'm actually using, I would not just copy it in different places in both the parsing macro and the printing macro. But again, this is just for our code samples. So let's paste that stuff over here. And let's do untype expr of this thing. Untype expr of that. And so let's see what happens now. Again, it prints out a whole bunch of things that we don't care because the printing macro is used in multiple places. Okay. Oh, wait, no. still did not do what we wanted. Untype expr.unseal. Oh, right. Inline. So expr.unseal.underlying argument. Otherwise, inline goes inside, and it only does the recursive untyping if the type is on the top level. Okay. Let's see. Expr.unseal. That should work. Oh, wait, hold on. It's not untype expr. It's not untype expr. It's gonna be... I need to introduce the equivalent, because this is a term at that point. I just need to introduce the equivalent that. This is not going to be an expr. This is going to be a term, and it's going to... Right, this is we're dealing in AST land. We're dealing in AST land. We're not dealing in code land, right? Or expression land. So, term, let's call it term. And unapply, and there. And we're not going to be doing untype expr, we're going to be doing type. Okay, let's see if this will do what we want. Again, we only care about this. Oh wait, no, we're good. Look at that. Literal, constant, hello. Right, all of our type ascriptions are gone. Okay. Again, sometimes we might actually want to see them to know what the actual AST is. I'll just comment this out. If you want to remove the typed instances from your AST. Okay. Let's just show what this was originally. Underlying argument, show extractors. Okay. And la. Okay, here we go. So, okay, let's go back to where we were before. We don't care about this right now. What we want to do is we want to see this tree that this union represents, and we want to be able to parse it. Well, let's print it again just to see what it is. Let's see what it is. Okay, so it's this... Come on. It showed some compiler garbage, so I just reran it. There's got to be some way of silencing that. Anyway, so, okay. So here's the tree. Again, ignore object foo, ignore typed, apply, right? This is what we're trying to match. And again, this inferred here is an argument of type, so it's actually this. So we're trying to match this tree. So let's see if we can match this tree. So let's go from our printing macro to our parsing macro. So again, let's just put this tree in here. Well, we already did, but let's pretend we didn't. Okay. So let's try it. And yay, it does match. Okay, now let's think for a second. What are we trying to parse? We're trying to parse this construct. Okay. But we're trying to parse this construct independent of person, so this is going to be a random type, and this is going to be a random type. And the only real thing we care about, well, this is a query, this is a constructor of type query. We don't really care, we don't really want it to be a constructor of query. We want it to be of type query, right? We just want that. And then we just want that. Okay. So how do we get that? Well, first of all, it doesn't have to be type ident of person. Well, that's an issue because that's not what we want. It should be able to be something more abstract, like any old query. So this is where we have to start playing with things a little bit. What we can do, for example, is instead of query of person, let's say we could just create a regular old value, val v equals to that. And this thing, let's see, oh, the second we declare it, it'll throw an exception. Well, that's a problem. So, right, inline def makes it not actually run it, but keep the syntax tree. Okay. Well then, right, but that's not what we want. We want something typed. So let's see, what happens if we do query of person there? Let's see, what if we do, oh, wait a minute. What if we do some query of person? What if we do some query of person and it's not in line, it's just a value, and we assign it to null. And then if we just do v union v, okay. So, all right. Okay, what? Right, it doesn't match anymore. But what does it look like now? Okay, we have an ident v union. What's the type of this thing? So we want to know what the type of this thing is, but it doesn't tell us, right? It's type apply that of some type, but we actually want to know what the type of v is because it's query of person. So we want something that matches something union something else. But we want the type of whatever this thing is and whatever this thing is, right? That's the other argument, right? We could do, or we could do like A, and we could do B. So we can do A and we could do B, right? So there, we can print that. So we just, sorry, compiler stuff. More garbled compiler stuff. Okay, save, run. There we go. Okay, so we want this and this to be a particular type. So how do we limit this to be a particular type? I mean, this kind of makes sense. So if we do this, right, which is actually a fairly simple construct. This is a fairly simple construct, right? It's not, it doesn't have to be, right here we did type apply of ident and then, right, because this was person, right? This was literally matching query of person, right? That's why there's type ident of person, right? That's that argument here is type apply on query. Type apply means this thing, right? If it was If it was parentheses, it would be apply. But it's not parentheses, it's brackets, so it's type apply. Okay? So it's type apply of person. Type ident means a type identity. In other words, freaking class. So type apply a class of person on query. Okay, but that's not what we want, right? And by the way, if we just want to know exactly what that is, let's say query of person, right? Query of person, we'll ignore that, right? Type apply, ident of query on person, right? That's what this thing is here. But we don't care about any of that, right? What we want is some old query union with some old other query, right? That's what we actually want. So what we want is, right, something more like this. So except for the fact that we want to control what the type is, and not just any identifier A and any identifier B. All right, so how do we do that? Well, first of all, let's just go in here, and then Okay. So, right, we just want some A, not just any identifier, but some A, some B, and we want to limit what the type of this is and what the type of this is. By the way, this will match. Like right now, it will match. And what you can even do is you can print out, let's say print line A is, add S there to be able to put dollar sign values. A, B is B, and do like dot show, I think, if you want to be able to show their values nicely. Okay, okay, that's not very helpful. Let's see, A is what? A is, let's see if we just do that. Is that helpful? Yes, oh, there we go, ident A, ident B. Or again, you could do directly on any expression, you could do dot show extractors. Dot show extractors. Okay, that, well, happens to be the same darn thing. Okay, so we can pull out A and B, we just want to limit what their classes are, right? Because it's theoretically possible that somebody, let's say that somebody creates his own DSL, object my DSL, or trait my DSL, right? And then creates something like, let's say trait query, right? And on it declares a union, right? We don't want it to match any old union or on any old blah, right? We don't want it to match any union, right? We actually want to control what the types of A and B are. Okay? Well, here's where, again, this is just stuff I've got to show you. You can actually check types of things. And the way that you do that is this extremely special construct here. So the way that this thing works is that this thing says, is a subtype, or is something a subtype? So, for example, is the type of this value here a subtype of io.getquill.embedded? So here's how this works. So let's actually, before we, now, by the way, here's what we want to do, right? We want to say if A dot TPE, the type of A, one second, can we do that? Oh, right. This whole thing needs to be a Boolean, so it's not like it's complaining, oh, this whole thing is not a Boolean, right? If we do that, then obviously it'll work. Well, except for you can't compare that to true, but right now I won't see any red lines because it thinks it's a Boolean. Useless. But anyway. Right, that's why there's a red line. It's like, oh, the thing inside of this if needs to be a Boolean. And that's why when I don't finish the statement, it says it makes an underline on A and saying that it has to be a Boolean. Totally irrelevant to anything we're doing. Like, we haven't even finished the expression yet, but already it's telling us that the expression is wrong. Okay, well, that's what you get when you include error handling as you type, and you don't have something like logic that says, okay, wait a second before, after they start typing, wait a second before you type check. Whatever, IDEs. I love IDEs. I have no quips with IDEs. But anyway, so, except for many of them. But anyway, so, okay. So this is a subtype of, and then we have to use something like this funny syntax that I'll explain in a minute. io.getQuill.query. Okay. If A is a subtype of io.getQuill.query, and B is a subtype of io.getQuill.query, then we can do this. But again, this is what I think it should be. I don't know that this is actually right. So before I'm going to put it into this condition here, I'm going to actually check if this is true. Right? Then let's say, yay, the type check is right. Okay. Let's see if I'm right. It looks like I'm wrong. Else the type check doesn't work. And I forgot to close the string. What? Wait, yes, I forgot to close the string. Voila. The type check doesn't work. Well, that's why I put it in here first, because it doesn't always work. Okay, so, all right, what is the problem here? Well, if the type is not a subtype of this thing that we hoped it would be a subtype of, right? We hoped it would be a subtype of query, and you need to unseal it and grab the type. Okay, this is just ceremony that you have to memorize in the great church of Dotty. But okay, what's a dot show extractors? Why don't we do a dot PPE? Let's just show the type. Right, that might work. Ooh, that's this weird term ref thing. Now, a couple of helpful commands when you're doing type. One of them is called widen. Widen will expand a type to be something more general as opposed to something more specific. Okay, this is a more general type, blah, 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 this whole giant thing here. Let's see, applied type of blah, 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 term ref, blah, blah, io.getQuill.query. This is what we want. Right, that's actually the type that we want. So it is it is a subtype of io.getquill.query. Oh, wait a minute. Query, oh, right, I forgot the fact that, okay, actually, hold on. Before we do that, does this work? Can you do show extractors on a type? You can do show extractors on a type. And can we, let's see, can we apply a pretty code formatter to that? Let's see. Where's our pretty code formatter? Code formatter.apply. Code formatter.apply. Can we code format this nicely? Okay. Oh, wait, no. Oh, right. Excuse me. You have to, again, you have to surround it with some object, otherwise it can't format it. That's just additional garbage, right? Because it needs to be valid Scala code in order to be able to format, or it needs to think it could potentially be valid Scala code, so we have to surround it by an object. And again, that's like a limitation coming from Java. Let's try it again. And, oh, it still didn't work. Why did this not work? Failed format cause error expected, but end of file found. Object foo. Failed to format, expected, but end of file found. Oh, oops. It's this parenthesis here that ends the code formatter, so I have to move the ending bracket inside of there. Whoopsie. Alright. There we go. Okay, so now we actually can look at this thing sanely. Okay, so what is the type? What is the type? Let's look at it. It's, again, more compiler garbage. There we go. For some reason, that if you compile something, or if you just enter some text, or, to change the file, and then instead of, like, compiling that millisecond, just wait, like, a second, then when it does this, I don't know, it seems better. Or it introduces less of this garbage. But anyway, so, termref, io.getquill.query. Now, we're applying person to io.getquill.query, and we're applying person to it. Okay. So that's what the type of this thing is. That's what the type of this thing is. And my type check is not working. Well, again, this is show extractors, so what happens if I do something like, what if I just do something like applied type blah, 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 and I do something like, instead of this if statement, I do something like, let's say, in fact, let's get rid of the whole if-else, And let's do something like a.tpe match case. And let's do all this sort of stuff here. Okay, so we're matching on this whole long, complicated type. And, well, we don't care about the argument, right? Because this is, again, this is io.getQuill.query, and this is the argument that's applied to it, which is person, because it's query of person, but we don't care about that. So let's just put a variable here, x, right? And we can, again, let's put it all together. So, case, print line, yay, it matches, and case otherwise, print line, nope, doesn't match. Okay, let's see if that works. Nope, doesn't match. Oh, wait. Yeah, yeah, it doesn't match. Why doesn't it match? We're printing out applied type, type ref, blah, 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 blah. Huh. Oh, we did dot widen. Let's do dot widen, right? Because again, if you don't widen it, it actually, right, term ref, it actually thinks that it's not the global type, but the type of, like, the actual term A, right? Remember how if you have something like val v equals to hello, well, what's the most specific type of v? Well, we tend to think of it as string, but it's actually not. The most specific type of v is either going to be the literal hello, right? When you actually think about what this thing is, the literal type hello, or the next thing that it's going to be is it's going to be the type of v, which is the term, which is itself. It's like a self type, right? When you think about a hierarchy of types, right? What is the most specific type of a particular term? The most specific type of a particular term is the term itself. It's a weird thing about type theory, right? When you think about like, here's an instance of a dog. What is the most specific type of this dog? The most specific type of this dog is the dog itself. Okay, whatever, right? That's why when you don't do dot widen, you get something like, sorry, that we premature victory. I didn't want to show you guys yet, but okay, when you do write term ref a no prefix, what is the type of the term a, right? And when I say the term a, I mean this thing here that we passed in. What is the most specific type of this? It's not query of person. It's actually term ref of a term reference. So that's why you need to widen types. Again, just remember that all you have to remember here is that if you do .tpe and you get some weird garbage like this, and you're like, what the hell, right? This is a, or let's say foo, and let's say bar, right? And I do foo union bar, right? And I compile that, and I say, what's the type of the first term, right? We grab it as a here, right? What's the type of this thing? It's term ref of foo. That's not a freaking type. Well, you just have to remember, no. You have to widen. You have to widen the actual type. Okay, so we're widening it, and now it's actually like the thing that we expect, which is io .get quill. Again, this is like printing compile. This is just again printing garbage from the compiler, right? Because you've seen how this thing just pops up randomly, right?
Yeah, yeah.
Yes, no. Yeah, you just have to ignore it, right? io.getquill.query, that's the type. And we're applying it to person. Okay, so we just widen and we get what we expect to have. Now, okay, so, okay, if we widen it, will we actually get this? We do. We actually get this, right? So to actually match the type of this thing, well, what you need to do is you need to do, in this case, we need to create a type match, right? That's what we've applied to it. So we need to say something like, let's comment that out and keep it here, right? If it's this, then true, else false, right? And then put that in there, put that in there, put that in there, and then if, and then this is going to be there, that is going to be there, this is going to be inside of an if statement, which is over there. And that's how we've checked the type. And let's compile it again. And it should match. And if it matches, then we know that we've compared the type of A. Right? And then we have to add, an additional and. If all of this and we have to do the same thing with B. Let's see if this works. And it does. Now, this is ridiculously lengthy, but, it works. It works. This will actually match. And it will match the correct type of union statement if A and B are the correct types. Right? And this is, right, we got this, right? This is we're going to improve on this several times, but this is when you first gotten it, this is what it will look like. It will look big and ugly. And so what we have to do is we have to iteratively improve. And that's the point. We have to iterate and improve and iterate and improve. So how do we do that? Well, first of all, we can encapsulate this logic, right? What is A? A is a term. So let's make a simple kind of def is query type. It takes a T, which is a term, right? And then all it does is encapsulates this. Right? And this returns a Boolean. Again, we don't have to do this in Scala. We don't have to type things always, but sometimes it's helpful. Okay, so not a.tp, but t.tp. Right? So then we can extract out is query type, A and B. Right? Okay. So this is actually starting to look reasonable. Let's try to compile it again, see that it works. Again. So this is like we're getting somewhere. So, and then, right, we can do something like if it's inside of io.getQuill, and it frequently will, right, maybe you can do like class name is class type, right? And then you could do CLS string, right? And then you could do CLS, and then you could, then this kind of becomes more general purpose, right? Then you can do is class type. Although again, like whether you want to match class names by string, this is one particular direction you can go. And again, this will work. So we're getting somewhere. We're getting somewhere. Now, here's the thing. Here's the thing, right? This is a totally legitimate path to follow. This is a totally legitimate path to follow. And for many things, we're just going to have to do it like this. But let's try and experiment a little further, right? Remember how we tried doing this thing right here? Right? Remember how we tried doing this funny thing here, right? Well, what is this guy right here? What is this guy? We did this guy dot unseal, right? Well, this guy right here actually should be, right? We're unsealing. What is this? What is this single quote bracket thingy, right? Well, remember, you can declare code like this, right? And this is going to be, foo.bar, right? But if you want to do something like a type, if you want to do something like, let's say, declare or like use a type query or something like that, it's going to be with brackets. Again, this is something like if you want to do val TPE, and then you want to do something like that, and then you want to do something like splicing this thing here. That's the bracket syntax. So it's basically like a quotation syntax for types. Okay, not so important, but the point is that this thing, right, something like this, right, foo, this will like create val f expert of foo or whatever, right? That's what that'll create. There is an equivalent for types, which is, let's call it t, which is going to be, I think it's going to be, what is the type of this thing actually going to be? It's going to be a type. So type is the equivalent for that. Just something to keep in mind. So here's the thing. Sorry, question? No.
No, that was just for cars.
So, okay. So this thing here is actually this thing here. Or we have the same thing down here. This thing here. This, right? This is this. Right? This, right? When you do this dot unseal, this is what you should get. Or something very similar to this. Because just like you unseal expressions, you can unseal types. Right? So when we say something like a.type is a subtype of this whole thing, what we're really doing on the inside is actually something like this. That's what this is supposed to do. So the question is, why doesn't it do it? Why doesn't this work? Right? This should work. So let's see if we could print this out. And again, we should be able to, right? Because we have this nice little code formatting. Right? Let's print this out. The type should be something like. Right? We can do this. And let's just show the extractors for this. Will this work? Oh, right, and we have to do .tpe, I think. Oh no, unseal? Yeah, we have to do that. So, okay, let's do our code formatter. In fact, just give me 1 second. I hate to type this over and over again. I should find a way to avoid having to do this or automatically remove it, but let me just code formatter. Let's just do apply in object. Or apply in foo. So we'll just do object foo and just do it directly in here. Plus that. Plus that. Okay. Okay. All right. Apply in foo. So let's just do that. So we'll just do in here. We'll do code formatter to apply in foo. Now let's see. Let's see what this will give us. Yay, it matches. Oh wait, right? We need to remove that because I think this print statement is actually being constrained to this if. So okay, let's see. Let's see. Ah, the type should be something like type select ident.io.getQuill.query. Why is this type select? It should be something like that. Why is it type select? Is it because it needs, well, so, okay. Right? Query needs a type. What happens if we do that? Oh! So that looks more right. Right? What? Let's see. That looks like it's correct. That looks like it's correct. Okay. Applied of... It looks more correct, at least. Let's see. Applied of applied type. Okay, it's a type select, list of any. Still not... Let's see. What happens if we do unseal.ppe? Because you can do that, I think. Because that's what we did. That's what we did up here. What happens if we do that? Applied type. Okay. So now we're getting exactly what we had. So this, see, applied type. Right, applied type. So this is what we expect to have, right? This is what we matched, applied type, type ref, term ref, compiler garbage, query, right? This looks correct. This looks correct. So okay. So that looks right? This is almost exactly what we matched on, right up here to get it to work. So wait a minute. Maybe we just made a boo-boo up here, and we just need to do .any, maybe in there, and then any maybe in there, seeing as how close it is, right? When you match them, maybe we just have to add that there. Let's see if that'll work. Aha! The type check is right! Okay. Okay. And now we can take this whole thing and we can actually replace it with a, and again, you know, this is the advantage of doing it. The advantage of doing it this way is that this is actually, you know, this is no longer strings, right? Over here, at the end of the day, it's strings, right? What happens if somebody chooses to refactor the query class, right? At the end of the day, right, this was before we introduced that there, right? This was query. This was a string. If somebody refactors the query class and changes it, well, that breaks. This is not strings. I mean, somewhere it might be, you know, some encoded form, but this is not strings. So, okay, right? And so now we've created a fully matched expression. And again, if you want to encapsulate, you could do something like def is query, and you could do something like, let's see, what is a.tpe? What is the type of a.tpe? I think it's a.tpe. What is the type of this thing? Sometimes you do tricks like assigning it to a value so that it actually tells you, and then you hover over the value. And if it doesn't tell you, you restart you restart the and then it tells you. Okay, so all right, it's qctx.tasty.type, and that of course comes from this quoted context up here to find. So tpe type equals to, and this thing here, and found. I think this is a dumb error that's not actually real. I don't think those are necessary either. Let's see. What if we... Okay, let's just compile it as is. What? Oh, not found. Oh. Let's just do my type. Because TPE is this, so it would be TPE.TPE if this was TPE. Okay. My type.TPE. Oh, wait, hold on. It's not my type. It's not .TPE. It's just that. Okay. Okay, so in this case, we can do TPE. Okay, fine. So then you could do is query, and then you could just do if is query of that, and is query of that. And a.tp and b.tp. Okay. Okay. Right, so we're getting better now. This is like substantially better. So this is, you know, this is what a lot of the code will look like. Now here's a question, right? So we have a fully typed expression. The type of A is known. The type of B is known. You know, we've got it. We've got it using this term. Can we make it any better? Can we make it any better? And the question is, well, maybe, right? The best thing ultimately to use is this case with this quoting syntax, right? Can we use this, right? The way that we use this, right, is A.union B, right? Can we do it like this, right? Because this is actually the closest to the way that it sort of appears here, right? It's the nicest way to do it. So can we do it like this? Well, this won't work, right? Because if we do this, it'll tell us no. Again, if it's A, it actually expects the code that it's matching to be A. That's not what we want. Right, so right? We don't actually want to parse user code with a variable A, not what we're looking for. Okay, there we go. Type must be fully qualified, or fully defined. Okay. So, right, that means that we just have to use this syntax, query, and again, the type, okay, the type T, again, because we don't know what the type is. And you can't do that inside of these quotey things. You can do it in many cases, but inside of these quotey things, you cannot do underscore. Sorry. T. And, okay. And now it's gonna, okay, not found query. IO. Dotty Quill? Did we not import query? Import IO. Get Quill dot query. You could do dot underscore, but I just want to do dot query for this example. Oh, that's why we needed to do it up here too. Okay, query. And let's try that. Oh, a.tp is not found. Why? Oh, wait a minute. What is A? A is going to be, oh, now it's going to be an expression, so we have to do dot unseal dot tpe. Look at that. Using this expression, it matches. So we've gone from something that was very ugly to something like this, which is substantially better. And now we've gone all the way to here. Right? Let's rewind a little bit. Oh, wait. We have no more history. Oh, whoops. All right, let's wind forward. I guess we'll just have to get it from the video. So we've gotten from something relatively ugly to this, and now we've gotten to something like this. Now, the other thing that I want, now, we can leave it as is, and this is actually quite nice. In some cases, I want to actually assign a type to B, right? So what we did for A, it's a query. I want to check that B is a query as well. Again, you know, in some cases, if it gets too ugly, I don't. But in some cases, I do. Why does this not require us to put a type? Because at this point, union requires the type of B to be the same as the type of A, right? If you look at the definition of union here, right, it requires the type of the argument to be the same as the type that came in, or basically the same as the type that came in. Again, what this is, I don't want to go into, but you can just imagine that U is T. U actually can be a subtype, you can be a supertype of T. So if it's query of person, you can union query of person with query of a supertype of person, like animal. But again, I do not want to go into the type theory of this. Sorry, already said too much. But anyhow, because it knows T, it knows what the other argument, what this thing is, and i.e. what gets passed inside of this parenthesis. But I kind of, you know, for the sake of being able to fully type something. Actually, I probably shouldn't do this. I probably shouldn't do this. This is the wrong answer at this point. This is the right answer, but I just want to show you, if you wanted to type both expressions, how you would do it. So the way that you would do it is like this. right? You would put parentheses around this just like we did before. Query of, and let's see if we can do TT. And we're good. And actually, let's make sure it recompiles. Yes, we're good. Now, what if we want them to literally be the same type? What if we want this and this? What if we want to force them to be the same type? We can't do that. That's going to break. That's going to break because duplicate pattern T, right? $ means extracted. So this is where the syntax type T, and you declare it like that, and then you put these squiggly quotes around it there. And so now it will, well, again, it works, but it will force it to only match when this argument, when the thing being passed into here and the thing being passed into here are literally the same type. So this is super restrictive. Again, the types of, you can do, right, typically something like a union, right, union query of person, right, this is going to be query of person, query of person. You're going to expect the same type. Strictly speaking, it doesn't have to be that, but realistically it sort of is. But again, the reason for this is more complicated. The reason why it's typed this way is more complicated. Actually, I just remember it has nothing to do with the fact that this can be a supertype of person. It's actually something else. Sorry, just don't ignore what I said about that there. Sorry. Why it has to be this type is more complicated. But anyway, in almost all cases, they have to be the same type. But again, because the type signature itself takes care of that for you, you don't have to actually explicitly type both of them. You can explicitly type one of them, and this is definitely good enough. I just wanted to show this to you because you might have to use it. So anyhow, so this is the journey. This is the journey that we went through. This is what we're trying to match. Originally we had this. Actually, we didn't have this. Originally we had, right, like we had is query type. That's what we had originally. Right, originally we had that. Then we did finally we got to that. So, ultimately the answer was doing a quotation syntax, something like this. And again, you can try it. Right? Like, you can try it. You can try doing something like this from the start. It may or may not work. That's the thing, which is why, I went through this whole exploration exercise. So, let's see. What happens if we take this thing and put it in? This is query parser. Let's go to the query parser, and let's actually try to put this thing in. Let's put it at the end of the query parser. Let's do something like that. Now, for now, so okay, so let's do that. Let's do that. Now we need to actually build the AST, right? We need to actually build this. That's the point. So we need to build this union object. But again, so hold on, let's see. AST parse. Change the name of it. AST parse. Sources A, B in this case. So we just take whatever's in here and whatever's in here and recursively parse it. The same as we did here, except we call it AST parser instead of AST parse for the reasons of inconsistency, which is no reason. So, okay, we have it. I think we also, unfortunately, notice how I have query and entity query. I think we also have to add entity query because entity query is a subtype of query, but again, parsing is not covariant. It's invariant, so it doesn't like actually follow the subtype hierarchy. But anyway, covariance and contravariance, by the way, is just something to look up. Just something to look up and then sort of to understand. Covariance, if you think of like the types of things that could exist as this big hill, right? At the top is anything and at the bottom is nothing. So, you know, you have dog. And then at the top of the hill is going to be like anything. So dog, and then we go up the hill and it becomes animal, and we go up the hill, or we go up the hill from dog and it becomes mammal, and we go up the hill and it becomes animal, and we go up the hill and it becomes entity or living thing. We go up the hill and it becomes I don't know, carbon construct, and we go up the hill and eventually it becomes anything. We go, and that's called, roughly speaking, that's called contravariance. Covariance is going the opposite. Covariance is going to subtypes. So dog becomes Labrador, Labrador becomes spotted Labrador, and then, you know, further down the hill, and then, you know, you become like spotted Labrador with 3 spots, you know, 3 spots on one side of the body and the other, right? You go into increasingly specific descriptions until eventually you're so descriptive that you like describe every subatomic particle, and then you flip one, and then you're referring to something that doesn't even exist, which is nothing. So the most specific type in any type system is nothing. Java does not have a type called nothing because its type system is not built to be sufficiently powerful to be able to express that. But it only has object, which is at the top of the hierarchy. The bottom of the hierarchy is nothing. So the most specific type of anything is nothing. Nothing is a subtype, is like the widest subtype or the narrowest subtype. But anyway, again, invariance means it will not travel up or down the hill. Entity query is a subtype of query, but it will not travel up and down the hill. It will only stay with this. So, unfortunately, it doesn't. That's just the way that it is. But anyway, sorry about that digression. I know it's getting late. So, okay, let's see if this will actually work. Right, let's go to our mini quill test and let's give this a shot. We are parsing query schemas before. We want to try unions. So let's try query person. Right? Query person dot union query person. And did we miss a parenthesis somewhere? Is this going to blow up? Let's see. It might. Do 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 do. Oh no, it blew up. It blew up. Match error query schema. Mini quill test. It doesn't like this. Okay, query creates query schema, by the way. Just, oh, right, that's because we modified the parser to do this. I don't think we need this anymore. Right, because we modified the parser with this, it might be crashing, I think. Oh, no, no, not true. Why is this blowing up? Let's see. What is the type of query schema? It's entity query. Okay. Where is this blowing up? Oh, of course. This isn't blowing up in the parser. It's parsing just fine. Again, this is why it's kind of important to add some print lines to show you where whether what you're doing is actually right or not. Either one of these. Yay! It works. So, yes, it does match. So what we've done succeeded, except that, again, it blows up here in the lifter because we can't lift a union object. So let's go to the lifter. So we have to add unions to the lifter and to the unlifter. So we've seen this before. We need to have a way to parse unions. So we need to add it to the lifter and to the unlifter. Let's see. So here's the main clause for lifting things. And let's see, case. We have all of these cases. So let's add a case for lifting unions. Case union A, B, right? Union has only two clauses. And again, it's just, we need to lift it. Union. And then we need to recursively lift the stuff inside. So that's going to be, so right when we need to call stuff recursively, it's going to be lift AST of A, lift AST of B. And this is going to be, oh, right, and of course we need to put a $sign because this is being spliced. And again, I will help with writing the lifters and the unlifters. If you don't get the pattern, I will help out with that. So we need to add it to the lifter. And we need to go to the unlifter and do the same thing. Again, lifter and unlifter are mirror images. So we add, let's see, we did lift base. So let's add it to unlift base. So case union. And this is going to be, and inside is going to be A, B, and we're going to go to, and we're going to, again, just like we recursively call the lifter, we recursively call the unlifter. It's going to be union. Union of unlift AST of A, unlift AST of B. Okay. Let's see if this will work. And, oh, whoops. Not unlift. Unlift. By the way, I've mapped Alt-K to clear terminal. If you're like wondering how I keep clearing it, if you go to Preferences and Key Maps in, Preferences, Keyboard Shortcuts, if you do click on this, you can actually record a shortcut key and see what happens for that shortcut key. So I did terminal clear for Alt-K. And this is useful because, you know, you want to clear your terminal because it can get filled up with a lot of crap very quickly. Anyhow, so, and voila! Here we go. Here's our AST. Now, let's mini quill test. And are we running it? Let's run it. All right, let's see if we can actually produce SQL. And we can't declare the variable output twice. Let's just call it Q here. Dynamic query detected. Quotations. Why is it? Okay. Oh, yes. Again, val has to be inline def in Dotty. Let's see if that works. And voila. There it is. There's our query. There's our compile time query. Select union, etc., 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 etc. There we go. We have added a clause to the parser. We have figured out how to parse it. We figured out different ways to parse it. We added a lifter. We added an unlifter. We've gone all the way through. And by the way, this is not, this is not the last time I will go through this process with you guys. Like, we will go through this process together until you are bored of it.